Ooh, familiar names. I like that.
Hello, everyone, and good morning or good afternoon, depending on where you are around the world. My name is Noah. I'm the head of marketing here at PractiTest. I'd like to welcome you for this month guest webinar by Dijkstra. I probably mispronounced it, despite the fact that I've made some preparations, but not that bad. I'll start by introducing PractiTest for those of you who are not familiar with who we are. So PractiTest is a centralized testing hub, essentially an end-to-end enterprise-grade test management platform which powered QA intelligence and AI. Essentially, we connect everything related to testing, regardless of the tool you're using, all the way from requirements, user stories, to the core execution of our platform, which is testing, and then reporting issues to any one of the logos you can see here, but other integrations are also available. We are a SaaS solution, very common in 2024, compliant with all the needed regulatory requirement, loved by our customers. You can see some of our badges right around here. As I mentioned, we are an end-to-end, we provide end-to-end testing modules all the way from planning and vision, which is typically happening in a third-party tool, but can also exist as a standalone on our platform. We have two core testing modules, test library, in order to enhance and to encourage people to reuse test cases in order to improve efficiency, and test sets and run module in order to improve organization of testing. We have an issue model for unfortunately report issues when those occur. This is part of what testing involves, and then reports and dashboards in order to provide measurement, as we believe by concept that we do testing in order to support our customers in providing better quality products. That's the end game, that's the goal. We do tests to enable this, but we provide very deep and very robust reporting, very detailed reporting, so we can report the results to any relevant stakeholders. Among our customer base, you can see customers from multiple industries, software and technology, of course, but we also see large customer base in the healthcare, financial industries, retail, education and government, and other additional industries from all around the world. I told Bas earlier that some of our customers, some people who've signed up for this webinar are also from APAC region, which will be receiving the recording. A good chance to mention this. If you have signed up or you need to stop at any point, we are sharing the recording with everyone who have signed up. We run a live training and Q&A session twice a month in order to, if you'd like to see the platform for yourself. So we invite you either to reach out to us and sign up for a demo, but or sometimes you don't want to commit, you just want to join the session and see it for yourself. So we run an open training session where you can join and ask dedicated questions. And that was a short intro. I know most of you have signed up to hear Bas. So that's, I want to thank you all for joining us. A few house cleaning session. As I mentioned, this webinar is being recorded. At all time, there is a Q&A option to ask on the chat, so you can ask questions. Sometimes, depending on sometimes Bas will answer them in the end of a session. If there's anything technically that you need to share, feel free to use that. And without further ado, Bas, I will hand over to you. Thank you.
Thank you so much for that introduction, Noah, and thank you for having me and for organizing these webinars. I know a lot of time and effort goes into them, and I appreciate it, and I'm pretty sure that everybody who's in the audience today appreciates it as well. So thank you for that. Awesome. What I want to talk about today is, and that's probably no surprise because that's the title of the topic of the webinar, is how to solve the integration testing puzzle with contract testing. My name is Bas Dijkstra. I'm an independent test automation trainer and consultant from the Netherlands. I do quite a bit of work on contract testing. I have been involved with contract testing for, I think, 4 or 5 years now. And today I would like to show you what contract testing is, how it works. So live demo will definitely be part of it. But I want to start with what's the problem that we're actually trying to solve here? Because tools are good, tools are nice, tools are interesting, but tools are only useful when they actually solve a problem. And with contract testing, I think there's definitely a problem to be solved. So let's dive into that first. Um, so as most of you probably know, lots of software systems these days are highly distributed. Um, I don't really know what microservices, but because if I ask 5 different people for the definition of microservices, I get 6 different answers typically. So, but the problem that we're talking about today, the problem that we're trying to solve with contract testing is how do we test in distributed software systems? And of course, microservices-based systems are just an example of that. More specifically, contract-based testing is a technique supported by tools that is meant to find an answer to this question. Are all these individual components and services able to communicate with one another? In distributed software development, different teams, different departments, different organizations sometimes are responsible for developing, testing, deploying, running, maintaining individual components. And hopefully, all of these teams, all of these organizations do testing on their part of the system. But at some point, you need to make sure that all of those individual systems, all of those individual components are able to talk to one another. Um, so for example, if we have a service that manages data around addresses, we probably have a team, the address service, the address provider test team, or development team, and I hope they test their work. So they do unit tests, they do some functional tests, acceptance tests. I hope they do some security tests. They do performance tests. And that's all great. That's all well and good. However, it's not enough. It's not the only type of testing that we need to do in distributed systems because it's not the address provider team itself that's going to consume this service. It's going to be other components, other services. So in this picture, it's other services. It could be a front end. It could be another type of component, another type of system. Doesn't really matter all that much. But we have consumers, and those consumers are typically the responsibility of another team, another department, another company. But they do rely on the behavior of this address provider. Um, and this is where integration testing comes in. This is where we want to make sure that the actual behavior of our providers matches the expected behavior that as the consumers expect it. Um, but there can be differences. So, for example, maybe the consumers expect some kind of field in the response body that looks like this for an address type, but the address provider doesn't supply it. Or maybe they expect that same type field to be formatted like this, but it's formatted slightly differently. Dates and times, always fun. Maybe the address provider returns it in a different format than is expected by the consumers. And then there can also be differences in expectations between individual consumers. So maybe the order consumer for a certain operation expects an HTTP 200, whereas another consumer expects an HTTP 201. Or maybe the order consumer expects a date field to be formatted like this, and another consumer expects it. The customer consumer expects that same date field to be formatted in a different way. And of course, the address provider will typically only return it in one of those two ways. So how we typically address that, or how we used to address this, is by integration testing. And the typical traditional approach to integration testing is the everything at once approach, which means that if our system consists of components A, B, C, and D, we deploy all of these components into some kind of shared testing environment. We need to make sure that they all are in the right state, with the right configuration, with the right test data, and then we try and do some integration testing. You can probably see and imagine that once the number of components grows, the challenge of getting this right also grows because maybe there's not four, but there's 10 or 100 of these components. Another problem is that you can typically only do this very late in the process when all of these components are ready. And because all of these components are developed in different teams, different departments, different organizations, all of these teams will have their own uh, development and delivery heartbeat. So getting all of those different components, of those different services into some kind of shared testing environment with the right versions, with the right state, with the right data, it's a mess. If you manage it, it's only going to be very late in the process. And this is what contract testing tries to address. Contract testing is a different approach to integration and end-to-end testing. And it's different from the traditional approach to integration and end-to-end testing in at least two ways. First of all, contract-based integration and end-to-end testing focuses on individual consumer and provider pairs rather than everything at once, meaning that instead of checking that A, B, C, and D work together, it checks that A works with B, that B works with C, and that B works with D. So it breaks down that puzzle into smaller, more manageable pieces. That's one of the differences. It's important. I don't think it's the most important. The most important and the big difference between contract-based testing and traditional approaches to integration testing is that traditional ways of integration and end-to-end testing is synchronous, meaning that if I want to test that consumer A and provider B are compatible, consumer A and provider B need to be in some kind of shared testing environment at some predefined point in time because they are going to exchange messages, requests, and responses. Um, Contract-based integration and end-to-end testing is asynchronous, meaning that sure, both the consumer and the provider will still have a responsibility. They still have work to do, both to complete the integration testing process, but they don't have to be in some kind of shared testing environment because all of the communication is done through contracts. Meaning that both the consumer and the provider can do their part of the integration and end-to-end testing process as part of their own local development and deployment lifecycle, which means that you can do the integration testing part a lot earlier than with traditional means of integration testing, because you don't need to wait and you don't even need a shared testing environment to do this. Or in other words, and this is one typically mostly for the marketing people, it's a shift left for integration testing because it allows you to do integration and end-to-end testing a lot earlier in the process. In the remainder of this talk and demo, we're going to see in a lot more detail how this works. However, before we dive into the demo and the tools and all that stuff, there's one important thing that we need to address, and that's different approaches to contract testing. When I talk about contract testing, when I meet teams and organizations that are interested in contract testing, they almost invariably start to talk about Pact. And with good reason, because Pact's fantastic. Pact's a great tool, great library. But Pact is a consumer-driven contract testing tool. And consumer-driven contract testing is only one of three possible approaches. So we have consumer-driven, there's provider-driven, obviously, and then there's bidirectional. I'm not going to talk too much about provider-driven contract testing, but I do want to quickly show you what the difference is between these three approaches, and then zoom in first on the consumer-driven testing contract testing approach, and then on the bidirectional contract testing approach. So with consumer-driven contract testing, it's the consumer who is in the lead. The consumer generates a contract through writing and running tests that is published to some kind of central contract repository. The provider then queries that contract repository to see, well, are there any contracts that I need to verify? So a contract is an agreement between an individual consumer and an individual provider. So in the example that we saw a couple of slides earlier, if we have one provider and two consumers, that provider needs to verify two contracts, one for each of the consumers. And that contract contains the expectations about the behavior of the provider for that specific consumer. So the consumer publishes the contract, the provider picks it up, replays the interactions to see if the actual responses returned by the provider match the expectations set by the consumer, uploads the verification results back to the contract repository, and based on those results, both the consumer and the provider can determine, are there any known integration issues, and is it safe to deploy the next version of my consumer or provider service into some kind of environment that might just be a production environment. Provider-driven contract testing is much more unidirectional. It's the provider that generates a contract, publishes that to some kind of central contract repository, and the consumer can pick it up and verify if they are compatible with that, but there's no feedback loop. It's very from provider. This is what public APIs do typically. So there's no conversation, no communication going on. This is it. It's provider that's in the lead that says, well, this is what I do. Deal with it, basically. And finally, there's bidirectional contract testing, which I'll dive a little bit deeper into at the end of this session. This is where both the consumer and the provider both publish their own version of a contract. And it's the contract repository that matches both the consumer and the provider contract and checks if there are any inconsistencies or incompatibilities. And based on that verification result, again, both the consumer and the provider can check, are there any problems here? If no, go ahead and deploy. If yes, we might need to have a conversation. And again, a lot of people, when they start talking about contract testing, immediately start looking into Pact and a Pact broker and all that fun stuff, which is great. But that's consumer-driven contract testing, which is the most powerful way of doing contract testing, the richest way, actually. But it also comes with some challenges that you need to overcome. And it might even be the case that consumer-driven contract testing is not the right approach for your specific context. So the first question that you should ask, if you ask me, is to determine what approach to contract testing is actually the best fit for my specific context. The good thing is you can change that. You can vary that approach from one integration to the next. So you don't have to do consumer-driven contract testing for all your integrations or bidirectional for all your integrations. You can pick and mix and see what works best for individual integrations. And of course, the first question is, well, do we really have a problem? And is contract testing really a potential solution to that problem? I'm going to share these slides with you know, at some point, I don't know if there's a way that you can distribute them. If not, this is probably a good way, a good time to make a
We can
screen.
definitely share them with the recording.
Awesome. Please do so people can have a look at these links. These links are sort of kind of recognizable. There's some YouTube links in there as well, and those are just horrible to remember. So if they can copy them from the slide deck itself, that would be great. Let's dive into consumer-driven contract testing. Again, it's the consumer in the lead, and there's tools that allow the consumers to write tests and formalize expectations about the behavior of the provider in certain situations in a contract. And then there's the tool also, these tools, these libraries also allow for automatically enabling the providers to automatically check that they meet the expectations. It's a great way for providers to it provides a safety net basically for providers so that they can develop and refactor without fear of breaking stuff because they know, well, I know what my because I have the contracts, I know what my consumers expect of me, and as long as I meet their expectations, I can pretty much do whatever I want. So that's great. And of course, for consumers, it's a great way to build trust in the providers and see that they don't accidentally break stuff. Um, there's a couple of interesting tools in the consumer-driven contract testing space. The first one is Pact, obviously. I referenced that before. And the nice thing about Pact is that it's open source, and B, it's available for a lot of different programming languages. And the contracts that are generated and verified are um, they can be parsed by all of these libraries. So if my consumer is written in JavaScript, because it's a front end, for example, that generates a contract, and the contract is a JSON file. The Packed Java library or C# library can parse that contract because the format is standardized, which means that Packed has a wide range of applications. There's docs. The docs for Pact are actually great. The one other tool that I know that does pure consumer-driven contract testing is Spring Cloud Contract, which I've not used myself. It's probably a great tool. Absolutely, I know people that use it and that are very happy using it. The biggest downside for me, the limitation for me, is the fact that it's Java only, and more specifically, it is part of the Spring ecosystem, which means that it only works if all of your services and components are Spring based. If that's true, you can probably get a lot of value from it. But if you have a more heterogeneous ecosystem, which also does non-Java stuff, Spring Cloud Contract is really not going to help you in that aspect. So that is why for the remainder of the session, we're going to talk about and look at Pact. So again, the way Pact works is a consumer generates a contract. That contract is then also input for a mock provider, which the consumer can use to test their own implementation. Contract is obviously given to the provider, and the interactions written down in the contract are replayed against an actual real running instance of the provider to see if that provider returns responses that meet the expectations that are written into the contract by the consumer. Of course, we need a way to we need a contract repository. So we need a way to distribute and version these contracts and the corresponding verification results. Doing that manually, not very efficient. So we need a better mechanism, and that's the Pact Broker. The Pact Broker is, again, a contract repository that enables automatic distribution and versioning of contracts and storing of corresponding contract verification results. There's two flavors of this Pact Broker. One of them is an open source Docker-based pact broker, which again is completely open source, free, but you need to configure everything yourself. You need to host it yourself. You need to run it yourself, which can be fine. But there are some limitations to it, but it's free. And then there's PactFlow, which is a commercially licensed. So a full disclaimer here, it's a commercially licensed tool with a free plan. So in the demo, I'm going to use PactFlow, but I'm not paying for it. I'm also not paid to show it. So I just want to get that out of the way. I'm using the free plan. So everything you see me do, you can do with the free plan of PactFlow. So the way the consumer-driven contract testing flow, what it looks like is we have a consumer, we have a provider, and we have our pact broker. The consumer generates a contract by running tests and publishes it to the pact broker. The provider downloads the contract, verifies that it can or cannot meet all of the expectations, publishes the verification results, and then both the consumer and the provider can use that information to determine, are there any known integration issues? Let's have a look at how that works in practice. So what I've prepared for you is, no, you did not do that. A project here in using Pact in C#. So both my consumers and my provider are written in C#. Let's have a look at my consumer tests first, because again, it starts with the consumer. This is my, so let's have a look at these ones instead. There we go. So what I've got here is a test that contains the expectations in certain situations when my consumer invokes the provider. So for example, again, my provider is a service that manages addresses. For example, I want to retrieve an address, and I retrieve an address based on an ID. Let's say that address exists. This is also the most comprehensive situation. The other ones are a little bit simpler. So that's the situation so it's basically, this is the HTTP 200 situation. So I said, well, given, so this is my provider state, because that is one of the things that you have to take into account on the provider side. If I want to make sure that an address actually exists, I need to make sure that it's in the database. And this is the way for the consumer to tell the provider, before you verify this behavior, please make sure that you meet this condition. And in this case, I want you to make sure that an address with a specific ID exists in your database. And once you've done that and you do an HTTP GET to that endpoint, as a consumer, I expect you to respond with an HTTP 200, so an HTTP status code OK, and an address that looks like this. My address should have an ID field that matches a certain regular expression. I have an address type field that is a string. So what you see here is basically pact and the C# bindings of pact ways of telling, well, it should be a string. It should match the type of this specific example value. For integers, we don't have match.type, but match.integer. And we have another way to say, oh, regular expression. So the value for the country should match the regular expression, because we only support addresses, for example, that are either in the United States or in Canada. And this is a very typical way to express the expectations about behavior. So I'm not too interested in actual values that are returned by the provider, but I want to make sure that the response that is returned by the provider can be processed by the consumer. And to be able to do that, I need to make sure that all the fields that I expect in there, that the data types of those fields match my expectations. And in some cases, also, I want to be a little bit more strict and say, well, I need this value that is returned by the provider to match this specific regular expression. Please don't use this as a functional kind of test where I test the implementation of the provider. Um, that's the responsibility of the provider development team. It's not something that it's something that you can technically cover with contract tests. It's not a very good idea to do so because it's a very expensive and cumbersome way of doing that. So what you're testing is not the implementation of the consumer. It's not the implementation of the provider, but it's whether the consumer and the provider are able to communicate. That's what you're testing with contract testing. And to be able to do that, I need to make sure that the responses that are returned by the provider are in the right shape for the consumer to process. When I run my tests, and let me switch to the order consumer side. When I run my tests, that's not what I expected. Let's use the customer consumer tests side instead. When I run my tests, a contract is going to be generated. Let me show you what that contract will look like. It's generated over here. So that contract contains all the interactions that are defined in the tests, as well as an identification well. A contract, again, is an agreement between an individual consumer and an individual provider. So both of them are listed in here, as well as some metadata. But what's most important is the interactions. So for example, if I create an address by an ID, so this is an HTTP post. So let me see if I can quickly find, does not exist. That's not the one. This is the delete. Let me see. Yay, this is the one I was looking for. So this is a get in the situation that the address with the specific ID exists. You'll see that it includes all the matching rules, all the expectations that we wrote down. So for example, here, so there's the response should contain a field that matches this JSON path expression, and its value should match this regular expression. What I can do now is, let me quickly see. I've got my contract in here, so let's publish that to my broker. And my broker is not in here. Go away. So this is my broker. I'm using packed flow here, and right now it is still empty. So there are no known integrations here, but that changes as soon as I publish this contract and I say, well, my consumer app version, because I need to specify, because a contract is associated with a specific version of either a consumer or a provider. So in this case, it's my consumer app version 100. I publish that to the broker. So right now it's being uploaded. And if I refresh packed flow, I see an integration has been added with a contract that is, as of now, unverified. Let me switch to the address provider. On the provider end, I've also implemented a bit of code, and what that takes care of is starting up an instance of my actual provider, downloading the contracts from Pact, from Pactflow, rather. So I've got my Pactflow instance here. And so we'll publish the results. My current version of the provider is 100. So what this takes care of is replaying all the interactions from all the contracts that it could find for this specific provider and publishing the corresponding verification results. So all of that happens when I run this test. So that takes a while, but it's going to run all of my tests now. And again, this downloads the contracts, replays the interactions, and publishes the result back to the broker, as you can see in the log file. And indeed, as we can see here, all the expectations here have been met, and there are no known integration issues. If I look at the matrix view, which is a tabular view where I can see exactly which consumer versions and which provider versions are compatible or maybe are not so compatible. Because when let me change one of the expectations here and say, well, for a successful delete, I don't expect a no content, a 204, but rather an okay. I need to also change that expectation in my test. And if I go back to my custom consumer, no to my custom consumer tests and run the tests again, this will, let me quickly delete this one. It will be generated again when I run my tests. So my tests pass. I have a new contract here. If I publish that, so this is a new version of my consumer with some updated expectations. Publish facts and then this one, and let's say my consumer app version is now 101. Because there's a new version of the consumer with some updated expectations about the behavior. And as you can see, if I refresh this view, I still have the information that consumer and provider versions 100 are compatible, but there's a new contract. And if I go back to the address provider and run the tests again, it does the exact same thing. So it looks for new contracts, downloads them, verifies the actual behavior. You can already see something failed. So this breaks the provider build, which is, I will talk about that in a moment. One of the downsides of consumer-driven contract testing is that, as you can see, changes in consumer behavior and consumer contracts can cause a provider build to break. But at least it's complete. It is visible now that consumer version 101 has expectations that provider version 100 cannot fulfill. And more specifically for this delete, the consumer expects an HTTP 200 in a certain situation, but the provider returns a 204. Back to this one for a moment. In the meantime, let me stash all my changes and check out a slightly different branch. There we go. We'll get to that in a moment. But this essentially is how consumer-driven contract testing works. So the consumer writes tests that generate the contracts containing expectations about provider behavior, and publishes contracts to a broker. Provider downloads them, verifies them against its own behavior, and publishes the verification results back to the broker. And then in a later step in the pipeline, both the consumer and the provider can look at that matrix using a tool called Can I Deploy, and see, are there any problems here? Now, what Pact doesn't do is point fingers. It's not saying, well, I see an incompatibility and that's the fault of the consumer or it's the fault of the provider. No, the only thing it signals is there is a mismatch between the expectations from the consumer and the actual behavior from the provider. It's probably a good idea if you start talking to one another. So that's also something that's very important to keep in mind. Um, some useful resources that I wanted to share here are, first of all, the documentation, which is great. It's a lot of documentation, so sometimes it takes a little bit of getting used to, but pretty much everything you're looking for is in there. The people behind Pact have also created a short video series, so each of these videos is under 10 minutes in length. It explains the problem with the traditional way of integration testing, as I did earlier. It tells you about contract testing and how Pact works. It gives you a demo very similar to what I did, just with a different implementation of Pact, being the JavaScript version. And it also goes into to what extent this kind of test removes the need for expensive large-scale integration and end-to-end testing, which is definitely also worth a watch. And I wrote something about this myself based on a Java version of all of the code and the examples that you saw in the demo earlier. So that's consumer-driven contract testing. Again, it's just one of the approaches to contract testing. It's great. It's very rich. It's super powerful, but it takes a lot of work. And there are a couple of things that it doesn't really do all that well. First of all, it's not a very efficient way of testing implementation details of a provider. Please don't use it to do that. That's the responsibility of the provider development team. Don't use contract testing to do that. It's also not very suitable to testing public APIs because there's no way that you can connect that you can include public APIs into this. There's typically no conversation going on. These public API providers typically don't even know who their consumers are. So it's not a great way to test public APIs. The people behind Pact have also wrote down some other situations where Pact is great and where Pact is not so great. And there's also a couple of challenges when adopting consumer-driven contract testing. First of all, one of the biggest challenges, and certainly something I've noticed myself, is getting provider teams on board. Consumer teams love this, and because they get to know, oh, I can tell the provider exactly what I want. For provider teams is, oh, but now I have to do a lot of work to prove that I can meet all of the expectations of all of my consumers. And that's quite a bit of work. Also, what you saw in the demo earlier, if a consumer makes a mistake in their expectations, it breaks the provider build, which is not something that is appreciated by all provider teams. So getting provider teams on board typically takes a bit of convincing and a lot of talking. Once they're on board and once they're working with, they tend to love it too, but it might be a bit of a hurdle to step over first. And also what I've noticed is that Getting testers on board is generally a little bit more difficult because you need to write code, and that code is pretty much at the unit testing level. So well, that's typically a developer job, not a tester job. Personally, I don't really believe in that distinction between, oh, this is a developer job and that's a tester job. It's a team job. But getting testers on board, especially the less the testers that are less comfortable, familiar with writing code, it can be a bit of a challenge, which means that a lot of it comes down to the developers. But what we're solving here is very much a testing problem, which sometimes causes a little bit of friction too. Um, so the team behind Pact definitely noticed that themselves as well, which is why they came up with a different approach to contract testing, and that's bidirectional contracts. Big disclaimer, this is a feature that's only available in Pact Flow. So there's also an open source Pact broker, but you cannot do bidirectional contract testing with the open source Pact broker. You can only do that with Pact Flow. This is how people try and make a little bit of money too. Um, so this is the consumer-driven contract testing flow. We've seen that. The bidirectional contract testing flow is simpler, more lightweight, and therefore easier to adopt. Typically, also, especially for provider teams, this is a lot easier to get started with. You pay for that with less a less rich way of verification. So, for example, basically what bidirectional contract testing does, it only checks data types. So you cannot do more sophisticated structural or value-based verifications there. So so you can do you can, as a consumer, I can say, well, I expect this field to match a certain regular expression. But the broker is not able to verify that. It can only check, well, ooh, the field is there and it's of the same data type. So you lose a little bit of flexibility, but what you gain is it's a lot easier to implement. Both the consumer and the provider publish their own version of a contract with bidirectional contract testing. The broker, so this is a piece of logic that's built into the broker. This also explains why it's a Pact Flow only feature. Checks for compatibility, and again, both the consumer and the provider can use the result of that compatibility check to see if there are any known integration issues and base their decision on whether or not to deploy on the fact whether or not there are any integration issues. Let's have a look at that as well. So I changed to a slightly different branch here. In this branch, my order consumer also has an integration with a payment provider because, well, we're running a shop here. At some point, my order needs to be paid for. So my order consumer has an integration with the payment provider, which is a public API. I've got some tests here. One of the nice things of bidirectional contract testing is that your consumer contract can be generated by Pact, but it doesn't have to be generated by Pact. In this specific example, I'm not generating my consumer contract with Pact. I'm generating it based on a WireMock mock implementation. So my WireMock, or rather WireMock.net, so the C# implementation of WireMock, listens to all incoming, records all incoming requests and outgoing responses when I run my integration tests here against the mock. And it uses that as input for it converts those to a consumer contract because my mock implementation will contain expectations about the behavior of my actual provider. So I can use this to generate a consumer contract. So if I go to, I think it's already in here, so I'm not going to bore you with running the tests again, but this is what the contract will look like. And this is all, again, this is all generated from the traffic that goes to and from my mock provider service instance. I can, there we go. I can publish that. And this is this one. This is also for my consumer app version 1.0.0. So let me publish that. Ooh, I forgot to include publish there because this is not a command. This is what you get with live demos. So I'm publishing my contract, my consumer contract here, which should now also be visible in my broker. There you go. So this is my consumer contract. My provider contract. Right now, Packflow only supports one specific format for provider contracts, which is an open API specification. I can publish that to the broker in a number of different ways. Right now, what I'm doing is I'm just making a put call to my Packflow endpoint telling me, well, I am the payment provider. And more specifically, I'm version 1.0.0 of the payment provider. And this payload, this is my open API specification, just base64 encoded. So I'm actually publishing the YAML file containing my provider specification, open API specification to Packflow, and Packflow matches that provider contract with the previously published consumer contract. So I sent this to Packflow, it accepted it, and if I refresh here, it says, yay! Your consumer contract and your provider contract are compatible. And I can even look into, well, what did my consumer contract contain? Again, this could be a contract generated by Pact, but it doesn't necessarily have to be. And this is my provider contract, which is basically just an open API specification. So that's bidirectional contract testing. Again, summarizing, a more lightweight version of contract testing, easier to get started with, easier to implement, doesn't take as much convincing for the provider teams, but you lose some flexibility and power to do more sophisticated matching and more sophisticated definition of expectations. Well, you can define them, but they are not going to be verified as in as much detail. I've included some resources for further reading into the slide deck as well. And before we move to the questions, because I see we've only got a couple of minutes left, and I definitely want to take some time to do the questions. I want to make you aware of a book that is still under the Manning Early Access program, but it's a great book. It's written by two friends of mine who are also very active in and very knowledgeable about contract testing, called Contract Testing in Action. And it's a great read if you want to know a little bit more about contract testing, the different approaches to contract testing, and again, what problem are we solving here, and how does Pact and Packflow work to help you solve those problems. All right, we've got a couple of minutes left, and I want to be respectful of your time. So this is probably a good time to go to the Q&A, Noah.
Correct. I think that you perhaps answered one of the questions already, but I will read it so you can address it and refer it.
Yes, please.
Cheryl asked that share that her team, which is mostly developers, is hesitant to adopt contract testing, preferring manual tests due to the concerns about changing mock data. And then the question was, how should I demonstrate them that contract testing adds value and work well with manual and traditional integration tests? Then she mentioned, she or he, I think it's she mentioned that in previous company, I was writing contract tests, but here there is resistance. That's why I'm so curious about your answer.
So the nice thing, you reference, first of all, thank you for the question. You reference the use of mock data. The nice thing about contract testing is that you don't really use mock data anymore. So you use actual examples, but you use a real instance, a real provider implementation, instead of having to rely on a mock instance of your provider. And we all know what happens with mocks. They are fantastic until they're not. With contract testing, you're generating your contracts with a real instance of the consumer, and you're having those contracts verified by a real instance of the provider. So, and yes, there's some mocking in between, but that's just a nice to have. It's not the main purpose of this. So that's what I like about contract testing, is that it breaks down that puzzle, but it doesn't replace parts of that puzzle by just testing against mocks. Is this the solution that works everywhere and that's the best and everybody should do it? No. And I can see, I've seen that people being hesitant too. Sometimes because it takes them a while to understand the concept. Sometimes just because they say, "Oh, but that seems like a lot of work," which is true. In some cases, again, especially for consumer-driven contract testing. But what works very well for me is just building out a small example in your context and saying, well, if we keep on relying on mocks, we wouldn't have caught this issue, this specific incompatibility between a consumer and a provider. And with contract testing, we can. So once people see an actual example in their context, you could just show them the recording of this webinar, but that's my context and my examples and not your context. So what works very well for me is just build something that works with your service and show them, well, with contract testing, we can find these integration issues, which we might not have found if we kept on relying on mocks or of course, you can catch all these things with manual testing, which is testing by humans. But that typically takes a lot more time, a lot more effort, and it happens later on in the process, which is expensive.
And the last question that we have, we are on top of the hour, but I'll just answer it. You can address it. You can answer it quickly. And that was from Damien asking, if I'm a provider with many 30 plus consumers, is a provider-driven approach more common?
It depends, and mostly depends on. So I'd say consumer-driven contract testing doesn't work very well with you if you have many consumers, because, well, you just get bombarded with all these expectations from all these different consumers. Depending on how well you know your consumers. So if all of these consumers are internal, it might work. I would probably recommend a bidirectional approach first, or just say, well, a provider-driven approach is basically just it's similar to just giving your contract, your open API specification to the consumers and say, well, I tested this. I work I work according to these specifications. Good luck. There's no real conversation going on there. And if you want that conversation between your consumers and your providers, I would actually recommend looking into the bidirectional testing approach for this large number of consumers. You could try the consumer-driven testing part, but at some point your provider might get overwhelmed just because there are so many different expectations with so many provider states, and with such a high number of consumers, the risk of a conflict of interest where one consumer for a certain situation expects X and the other expects Y is just very high. And again, that doesn't only impact the consumers, it also impacts the providers. So with this high number of consumers, I'd recommend looking into the bidirectional contract testing approach first and see if that's enough, providing you with enough confidence to not have to dive into the more elaborate technique, which is consumer-driven contract testing.
Thank you.
I hope that helps.
So, I mean, if you have additional questions, I will offer for you. We are on the top of the hour, so I want to thank everyone, thank Bas, and I want to thank everyone who have attended. And yes, the answer was, and then Damien just responded, that was a great overview, and he thanked you. So that would be a yes for that question.
You're welcome, Damien. Thank you very much.
I want to thank everyone who joined us today, and will be watching the recording. As I mentioned, we want to thank Bas. We invite you all to come visit our website and learn more about PractiTest, and we will be more than happy to see you on our upcoming webinar. We host them on a regular basis. We're going for a short break for summer, but then we'll have additional couple of webinars in August and September. So stay tuned and keep track of our correspondence via newsletter. Thank you all. Nice meeting you.
Thank you. And thank you to, again, Noah, for hosting and for making this possible. And thank you to all the participants for taking the time out of the day to join us.
Have a good day.
Have a great day. Bye-bye.